Hi, this is Mark Espenheid again, and we are looking at the final installment of our Introduction to Geometric Series. Geometric series are a summation, or we're adding up the individual terms of a geometric sequence. And in the last video, we derived the equation that gave us Sn, summation for n number of terms, equals g1, that's the first term, multiplied by r to the nth power minus 1. N here again is the number of terms. R here is the common ratio. This is all divided by r minus 1, r being that same common ratio. Let's look at some examples. We began earlier with the example of a geometric sequence that ran 2, 6, 18, 54, 162. Of course, it keeps going from there, but these are the first 5 terms. So in this case, G1, our first term, is 2, and here we come up to the 5th term, n is 5. This, of course, would be G5. I could say that G5 equals 162. Okay. Let's take this into the format that we have here. We are going to try to add up these 5 terms, and we get S5 equals G1, and this is going to be 2. And then R here is the common ratio, or the multiplier. In each case, this is 3. So I'm going to do 3 to the 5th power, then minus 1. Let's close those parentheses up. And then we're going to do down here 3 minus 1. So just to reiterate here, the first term there is 2. The common ratio there is 3. And we're adding up 5 of those terms. Checking over on a calculator, I see that 3 to the 5th power is 243, so let's put that in. We get here 243 minus 1. And we come down here 3 minus 1. So this is going to be 242 divided by 2. And of course, the 2 on the top and bottom cancel there, and we're left with 242. Okay, let's try another. Let's take the number 5. Start with the number 5, and then we're going to go 5, 10, 20, 40, and so on. And let's say that we're going to go through 10 terms, so n equals 10. So again, here we can say that Sn equals G1 r to the nth power minus 1, and then on the bottom, r minus 1. We can put in what we know here. Coming back up here, we see that the common ratio r here equals, in this case, 10 over 5, same thing as 20 over 10, same thing as 40 over 20. That, of course, is 2. So S10 through 10 terms is equal to the first term, G1, that's 5, and then 2 to the 10th power minus 1, close those parentheses up, and we get 2 minus 1 down on the bottom. Okay. So 5, 2 to the 10th power, let's check it out. It is 2, 4, 8, 16, 32, 64, 128, 256, 5, 12, 10, 24. Let me step aside to a calculator here just for a second to double check myself on that. 2 to the 10th power is indeed 1024. And we're going to come down here. 2 minus 1 is 1, so I don't have to really worry about that afterwards. So we're really looking here at 5 times 1023. And that is 5,115. Okay. So there are some examples of how to apply the rule that we derived. This is the summation of a finite number of terms of a geometric sequence. And when I come back tomorrow, we'll take a look at how to add up, if possible, an infinite number of terms in a geometric sequence.